Hello and welcome back to Algebra 1 Honors. This is lesson 7-1, which deals with ratios. Okay? Ratio are basically fractions. One number is compared to another number. Okay? The ratio of one number to another is the quotient when the first number is divided by the second number, and the second number is not 0. You can write a ratio in 3 different ways. Okay? The very first way you can write a ratio as a quotient using a division sign. For example, if I said the ratio was 7-4, okay? Let's look at this. The ratio of boys to girls, the ratio was 7-4, okay? Now, if I was talking about girls to boys, I could say the ratio of girls to boys was 7-4. Now, I can write this in 3 different ways. I could write it using a division sign, okay? And if I do that, I would go ahead and write it like this: 7 divided by 4. Okay, that's one way to write a ratio. Another way to write a ratio is as a fraction. I could say 7-4, or I could use a ratio by using a colon. 7:4. These are the 3 different ways that you can write a ratio. Okay, you can use ratios to compare 2 quantities of the same kind, such as 2 heights, 2 masses, or 2 prime time periods. To write a ratio of 2 quotients, we have to do the very first thing is we have to make sure that we have our measurements, okay, are expressed in the same units. For example, if I was going to compare 20 minutes to, let's just say, an hour. As you can see, they're not in the same units. I have minutes and I have hours. Now I can convert by using each one of these. If I want to use minutes, I would say that the ratio would be 20-60. Now, all the time we always go ahead and we reduce these guys. Well, it would also look like this: 20/60, and we can reduce this to 1/3, okay? So, for every 1 second, it's 3 seconds over here. All right, and that's what they mean by using the same measure. Using minutes, use minutes. Now, what if we're using hours? Well, an hour here would be what? 1/3 of a minute. Okay, 1/3 of a minute. An hour would be 1/3 of a minute. 2, okay, 1. Okay, so 20 minutes would be 1/3 to 1. Or if you wanted to clear this fraction, you multiply both sides by 3, and you would get 1-3, which is exactly the same ratio as you had with minutes. Okay, this is 1/3 of an hour to 1 hour. Okay. All right, let's look at some other examples. Let's look at an example if we had 25x to 20. Okay. Let's look at a few of these. Okay, 25x to 20. Okay, 25x to 20. We're going to see what that turns out to be. And I believe there's another x here. 25x to 20x. Is that what we have? Yes, in 9x squared y over 6, and 9x squared y over 6xy squared. Okay, if we look at the first one, we see that x over x will cancel out, and that will give us a 1 over 1. Now all we have to do to make this a good ratio is we have to reduce it. If we reduce it by 5, we'll get 5 over 4, and that's the ratio. 5 over 4, or it can be written like this, okay? Or it can be written like this, 5 to 4. Now over here, we're going to reduce the 9 and the 6. We're going to reduce it by 3. So the very first one will be 3 over 2, and then x goes into x squared. I'm going to leave an x here, y and the y squared. So this would be the ratio for this one, okay? X goes in x squared, leaves an x. Okay, we divide y here to leave a y on the bottom, and that's how we get that. All right? Now sometimes, okay, sometimes we have something like 9 inches and 5 feet. Let's look at a problem where we have different measures. 9 inches and 5 feet. Okay? All right, here we have 9 inches to 5 feet. All right, the easiest way to compare this is to convert everything into inches. Okay, well we have to know how many inches is 5 feet. Okay, and how many inches is 5 feet? 5 times 12 is 60. So what we're actually going to have is 9 to 60. This is in inches, or we can write it as 9 to 60. And if we go by 3, we would get 3 over 20. Okay? That would be the ratio. But what did we have to get 3 to 20 is we had to go ahead and make them the same measurements. If we're going to do inches, we have to make them all inches. If we're going to do feet, we have to make them all feet. Okay? Now let's look at this next one. It says, write the ratio of a height of a tree 4 meters tall to a sapling that's 50 centimeters tall. Okay, so 4 meters tall to 50 centimeters tall. All right, well we can do that. Okay, one tree is 4 meters tall. The other one is 50 centimeters tall. Okay, again, we have to decide for ourselves, are we going to make them all meters or are we going to make them centimeters? Let's just choose this time to make them centimeters. So 4 meters is actually 4 times 100 centimeters, or 400 centimeters, okay, over 50 centimeters. Okay, we can rewrite it as 400 over 50, and we're going to reduce it. Okay, 40 over is going to be, it's going to be 8 to 1. Okay, and that's the ratio. Okay, the ratio will be 8 to 1. Okay. Let's pretend that we change it to meters. We can also, instead of going centimeters, we can change it, leave it to meters. Okay, if I left it to meters, that means my tree would stay 4 meters. And 50 centimeters is actually what? A half a meter. Okay, so we can write 4 over 0.5. Okay, to clear the 0.5, we multiply everything by 10. We're going to get 40 over 5. And then we divide by 5 and we get 8 over 1. And as you can see, our ratio is always going to be the same whether we use the measure of centimeters or meters. Okay, the ratio will be the same. All right. Let's look at a couple more. Let's look at a couple more. Let's look at this one. It says, Jenna planted alfalfa and wheat on 160 acres of corn. On 160 acres. So she has 160 acres. That's how much she planted. And it says here that the ratio of acres of alfalfa to the acres of wheat is 3 to 5. So we have 3 acres of alfalfa to 5 acres of corn. All right, so to do this problem, we don't know what they're planted, but we're going to say X is going to be our multiplier for our ratio. So 3 times x plus 5 times x equals 160 acres. So we get 8x equals 160. Our factor, our x, is going to be 8 divided by 160, or 20. Now, to find out how much is in alfalfa, we take 3 times 20, or we can say there's 60 acres in alfalfa, and 5 times 20, or 100 acres in corn. Okay? Now, this isn't the answer. This is just what the factor is. It's going to be multiplied by our ratio to give us the right answer. So on a test, if you put down 20 and they're asking you for how many acres, you're not going to get it right. All right? All right, then let's look at this last one, which is similar. It uses ratios. Okay, it talks about the perimeter of a triangle. Okay, and it says this: the length and sides of a triangle are in the ratio of 3, 4, 5. Okay, the lengths are in a ratio of 3 to 4 to 5. Okay? And then it says the perimeter of the triangle is 24. Find each length. Okay, so the perimeter equals 24 inches. Find each side. All right, well, if the perimeter, we're going to have 3x plus 4x plus 5x equals 24. We add those together. 4 and 5 is 9 and 3, so we get 12x equals 24. And again, we see that x is 12. This is our factor that we're going to multiply our ratios by. This isn't the answer. So to get the answer, one of my sides is going to be 3 times 2, which will be 6. Another one of my sides is going to be 4 times 2, which will be 8. And the last one of my sides will be 5 times 2, which will be 10. Okay? And again, this is about ratios. Ratios are two numbers that are being compared with each other. All right? And this basically is the end of lesson 7-1, ratios.